So today on the menu is 12.3 homework and 12.4, which is geometric sequences. We're in Unit 7, but these actually belong here in Unit 7. I used to teach them as a separate unit, but since we're talking about exponential growth and decay, it makes sense that these would be here. Anyways, what have I got bolded here? I got number 1 bolded. It says determine if the sequence is geometric, arithmetic, or neither. So most kids, when they look at this, they might think that the ratio is 2/3 over third, which is 2. But then if you go back and you check, like maybe you check these, you'd get 4/3 over 1, which is 4/3. So it's not geometric. What it is arithmetic. It's arithmetic with a difference equal to 1/3. Because if I add a third to 1/3, I get 2/3. If I add another third, I get 1, and so forth. It's arithmetic. So a sub n must be the first term plus n minus 1 times d. And I just plug stuff in. The first term is a third. N minus 1, the difference is a third. I invoke the distributive property. And I would have a sub n is 1/3 plus 1/3 n minus a third, which just becomes that a sub n is 1/3 of n. I also bolded number 4. Number 4 is geometric. The ratio here happens to be a 16th over 32nd, which is a half. If you don't believe me, just type that in the calculator. You'll get a half, as long as you wrap. But anyways, so the formula for geometric is a sub 1 parentheses r to the n minus 1. Just write it down, plug stuff in. Anyways, the first term is a 32nd. The ratio is a half, and the exponent's n minus 1, and you're done. That's how hard those are. Next up is 7. These sequences are all small, but you're supposed to write a rule and find a sub 10. So this is a sub 4. I'm going to put out 4 blanks, and I'm going to put my 500 there. It says the ratio is 5, so that means to move right, multiply by 5. To move left, divide. That's what I'm going to do. I'm just going to move left. 500 divided by 5 is 124. See, now I have everything I need. The nth term is the first term of 4 times the ratio of 5 to the n minus 1. And if I want a sub 10, I plug in a 10. And I have no idea what the 9th power of 5 is on a Monday morning, nor do I care to invest the energy to figure it out. We're just going to assume I don't know what 10 minus 1 is either. There you go. 7,812,500. They get pretty big pretty quick because they are exponential growth or decay. I write a rule for the nth term of the sequence that has 2 given terms. When I saw these as a kid for the first time, it was actually at a math contest and I'd never seen it. So what I did is I did this. And I have a strong enough mind to figure out what the ratio is. I'm pretty sure it's 5. 5, 25, 120, 625, okay? Now I know formulas. Like this is, what I did right there is great for a short sequence. It is, but now I know formulas. I know this guy, that a sub n is a sub 1 r to the n minus 1. And I have this. And I have the first term. A sub 5 would have to be equal to the first term times some ratio to the 5 minus 1. And the nice thing is I know a sub 5. I hope you understand why I put a 5 there. And I know a sub 1. So 625 is 1 times r to the 4th. And I'm almost done with this thing. I really, really am. What I'm going to do is I'm going to counteract the 4th power with the 4th root. And I'm going to type that in the calculator. 625 rooftop 1 over 4. 125, 25, 5. That's disturbing. That is very disturbing. I bet what's throwing this thing off is it starts with a 1. Oh, that and I made a typo. That's the mistake. Ah, that's better. I was wanting a 5. So R is 5. Anyways, now the nth term is the understood 1, 5 to the n minus 1. So, like I said, that one's an easy one. You could use that technique on that one and probably that one. Maybe just drawing it out. This one, the numbers are kind of fugly. And you don't have the first term. So, anyways, I'm going to sit here and just write out formulas. I'm going to talk about ace of 4. It is 162, and it would equal the first term times r to the 4 minus 1, which is the third power. I'm going to talk about ace of 7. It is 4374, and it would equal the first term times r. And remember, this is n minus 1, so 7 minus 1 is 6. Okay. Now I'm going to solve this guy for ace of 1. And I have that ace of 1 is 162 over r cubed. And here's the beauty about mathematics. If you can write 2 equations, you can solve. I'm going to throw that right there. 4374 is 162 over r cubed times r to the 6th. If we do r cubed underneath times r6 up top, we'll get r cubed in the numerator. Sorry, I can't speak. Take my 4374, divide that by 162, and I get 27. 27 is r cubed, which means that r is 3. And again, going back to the ideas of substitution, I can plug that in right there. 162 divided by 3 cubed, which is 27, is 6. So the first term is 6. And now I have the stuff I need for my rule. Ace of n is the first term of 6 times the ratio to the n minus 1. Easy peasy, right? It is to me. Your task is to get as good as me. One day you probably will be. Find the sum, obviously show the work. This has a hint, it's not geometric. Because if you look at it, you're adding 4. Well, how many terms are there? Well, this is the first position, the second position, the third position. So we're taking the position and we're multiplying it by 4. So this has to be the 100th position, right? Makes sense to me. How many terms are there? Remember, n is always high minus low, add 1 back, right? 100th position, take away 1. Anyways, there's 100 positions. And now we have everything we need, if we remember formula. According to Gauss, the sum of n things for an arithmetic sequence was n over 2 times ace of 1 plus ace of n. There are 100 things, so 100 over 2. First term is 1, last term is 400. So the sum of 100 things is 50 times 401. Let's see, 5 times 4 is 2. That is 2,000, 20,005, 20,050. That should be my result. Check that, because it is a Monday morning. Yeah, 20,050. All right, what's up next? 16 is up next. Find the sum of the 4th through 10th terms of the sequence to find h of x is negative 4 times 2 to the x minus 1. That is definitely geometric. There's the first term, there's r. And I'm going to use the form that the sum of n things is ace of 1, big old set of parentheses, 1 minus r to the n over 1 minus r. And the first term here is actually that guy. N is 10 minus 4 plus 1. That's how we do it, which is 7. And to find the first term, I got to plug a 4 in. So what I got to do? 4 times a negative 2 to the 4 minus 1. What's that going to be? I believe it's, oh, no, I'm thinking something else. Just ignore me. I feel like it's negative 32, but I'm tired. It is. All right. We're finding the sum of 7 things. So the sum of 7, everywhere I see an n, I'm a 7. Negative 32, 1 minus. Because this ratio is negative, I need to make sure I wrap it in a set of parentheses. I just do. If this was an even power, that would be a huge deal, because if you didn't wrap it, it'd be wrong. With an odd power, it'd probably be all right. Over 1 minus r, a negative 2. I'm just going to use my T84 to do that. Negative 32, math, number, numerator over denominator. Whoops. Negative 32, parentheses, math, num, numerator over denominator. 1 minus, parentheses, negative 2, rooftop to the 7th. Assuming I don't know what 1 minus a negative 2 is. Good. Negative 1376. You see how hard these are with a formula? Pretty easy. 18. Find the sum of the infinite geometric sequence. S of n is ace of 1 over 1 minus r if possible. If not possible, state why. So the deal is it converges on 0 if the absolute value of r is less than 1. So when I glance at these, and this is what I'm thinking in my head, negative 2/9 over a negative 2/3, or sorry, a positive 2/3 should be negative 1 over 3. That's my ratio. And that's definitely going to be less than 1. So the sum of an infinite number of things is the first term, 2/3, divided by 1 minus a negative 1/3. This becomes 2/3 over 4/3, which is a half. Don't believe me? Push them buttons. Math, number, numerator over denominator. 2 over 3 divided by 1 minus a negative 1 over 3 is a half. And 20, the last one I'm going to do with you. Does this one converge? So r here, it's right there, is 6/5. And the absolute value of 6/5 is not less than 1. The series diverges from 0, has no infinite sum. That is that. I'm glad I got that done. I can go work on something else for a little bit.